What is electrolysis? By using electricity to decompose chemical substances in which a redox reaction is forced to take place is called electrolysis. What is cathode and anode? Redox, cat, and ox. That means reduction at cathode, oxidation at anode. What is positive and negative pole according to battery? Electrolysis of molten substance by inert electrode. No preference of discharge of ions. Positive pole attracts negative ions, vice versa. See, bromine formed at anode, lead deposited at cathode. Another example, electrolysis of dilute solution by using inert electrode. We have rubber bands are there, wooden piece is there in between. Electrolysis cell it is. Very dilute sodium chloride solution is taken. The graphite electrodes are also introduced in this. There is a partition is also present between the electrodes. 6 volts passed. Electrons transformation takes place. Na plus ions reach the cathode and Cl minus and OH minus and reach the anode. H plus released OH minus ions. H plus converts into hydrogen gas at cathode and OH minus ion convert into water and oxygen during oxidation. By electrolysis of dilute solution using inert electrodes, preference of discharge of ions according to electrochemical series. Negative ions go to anode and discharge in order of OH minus greater than I minus, greater than Br minus, greater than Cl minus, extremely greater than sulfate and nitrates. So OH minus ions discharge as it is more readily to give electrons than other negative ions. Positive ions go to anode and discharge in order Ag plus greater than Cu2 plus greater than H plus, extremely greater than other metal ions. So H plus ions discharge as it is more ready to accept electrons. Copper or silver discharges if they are present. See this example. Electrolysis of concentrated solution using inert electrode. We have Na plus H plus ions at cathode, Cl minus OH minus ions at anode. Observed. See hydrogen gas liberation at cathode and chlorine gas liberation at anode. Electrolysis of concentrated solution by using inert electrode. So by concentration effect, the ions to be discharged may be different from the dilute solution. Negative ion discharge according to the order of ease of to lose electrons. OH minus greater than, I minus greater than, Br minus greater than, Cl minus. Although OH minus ion is more ready to give electrons, however, due to concentration effect, ICl, I minus, Br minus, Cl minus are present in larger amount, then they will be discharged instead. Positive ions discharge according to the order of ease of gain of electrons, that is according to this. Silver, copper, H plus, this is the order. Ion discharge is same as the dilute solution unless mercury is used as anode. See here, electrolysis of dilute solution by using a non-inert electrode, that is we have copper electrodes used. In the copper sulfate solution they kept. Copper ions and H plus ions came to position, that is cathode location. At anode OH minus and sulfate came. So in this, copper gets deposited cathode. That is copper deposition. At anode, this copper will get dissolved. And the solution finally becomes blue in color. So in the solution anode, see, anode is completely losing its capacity mass, and over cathode the mass developed. Electrolysis dilute solution using non-inert electrode. Metal always give electrons more readily than OH minus. So positive pole, that is anode, metal electrode discharges and dissolves but not OH minus ions. Would the preference of discharge of ions be affected the pole, negative pole, by using non-inert electrodes? No. Metal solids always give electrons. Zinc nitrate electrolysis equation diagram. We have platinum electrode, zinc electrode is there. Dilute zinc nitrate solution taken. H plus ions and zinc ions at platinum electrode approach. OH minus ion nitrate ion at zinc electrode approach. Hydrogen gas liberates at cathode, and the zinc deposited at zinc lost its electrons at anode. Next, electrolysis of concentrated sodium chloride using mercury. So plastic covered wire is there here. The graphite anode is there. This platinum wire cathode. Here mercury is cathode, here, which is connected with platinum wire. Here concentrated sodium chloride solution is taken in this. Now Na plus and H plus ions came to cathode. OH minus and Cl minus came to anode. At anode chlorine gas is liberated. At cathode sodium metal deposit. Mercury prefers to form alloy with metal form. Concentrated effect is the reason. So why water? Because see, at cathode sodium mercury amalgam formed. At anode chlorine gas is liberated. Due to concentration effect, chlorine gas liberated. Due to reduction, sodium metal joins with mercury liquid, forms sodium amalgam at cathode. So overall reaction, if you see, sodium amalgam with water forms sodium hydroxide, hydrogen, mercury. So sodium hydroxide and hydrogen are the results. In the overall reaction at anode, if you see, that liquid mercury unites with the sodium, and sodium undergoes reduction, chlorine undergoes oxidation. So final overall reaction is this one. The sodium chloride solution becomes more and more dilute. Now, chemical cell, electrolytic cell function. What is chemical cell? A device for generating electricity by chemical changes. Electrolytic cell, a device for bringing about chemical changes by electricity. What is the type of reaction involved in a chemical cell? A spontaneous redox reaction takes place. Whereas in electrolytic cell, redox reaction formed due to force to take place. Cathode in chemical cell is positive, anode is negative. In electrolytic cell, cathode is negative, anode is positive. But the type of reaction takes place at anode cathode is same. Polarity of the electrode and its change as shown. See the pictures. So factors affecting the rate of electrolysis are increase the voltage. decrease the resistance, increase the current, speed up electrolysis. Next, uses of electrolysis. Extraction of some reactive metals, molten chlorides of metals, gives metals in the high metal in the electrochemical series. Molten oxide of aluminium, electrolysis gives aluminium. Extraction of aluminium, this diagram you observe, carbon electrodes anodes taken, series of carbon anodes taken. This aluminium is collected at the bottom of this tank. Molten Al2O3 is electrolyte with conductive materials. Carbon cathode, aluminium, molten aluminium collected. This is aluminium reduction equation. This is the oxygen gas at anode. Purification of metals. Copper metal purification also you can once again you can check it. Pure copper anode, pure copper is there cathode, and impure copper anode is taken. So copper sulfate solution taken, where anode gets decayed, that means its mass reduced, dissolved in solution, impurities settled at the bottom. So in this copper deposited at cathode, that copper melts at anode. When material is negative electrode made up of, what material is negative electrode made up of? What is the assumption? Yeah. Can check it. Electroplating of nickel. So in this object to be plated here, we can left side, right side we have nickel anode is the nickel sulfate solution taken. Ni2 plus H plus ions came to cathode. OH minus and SO4 2 minus ions came to anode. Nickel deposited, plated, and nickel anode dissolves. So can a plastic object be electroplated? No. See, silver nitrate solution. Iron spoon as cathode. Silver anode is there. Silver nitrate solution we have taken. Plating bath. Setup of electroplating silver on spoon. This diagram. Electroplating silver on metal cups. Here, criteria is that objects to be plated always place at negative pole. The electrolyte should contain the plated metal ions. This is the 2 points you have to remember. So silver gets deposited. Silver gets dissolved. Can we use the method to plate zinc on a coin? The setting only suits for silver, copper, nickel plating only. Production of chlorine hydrogen hydroxide electrolysis of concentrated brine solution. So this is the concentrated brine solution type. In this, use mercury, sodium amalgam forms, chlorine gas liberates at anode. See, These are the overall reactions we saw in mercury electrode cases. So at cathode, useful chemicals like sodium hydroxide, hydrogen, chlorine gas, obtained. Analyzing aluminum. The resistance to corrosion of aluminum can be enhanced by analyzing it using electrolysis. A thicker protective layer of aluminum oxide is formed on the surface of aluminum. We have taken dilute sulfuric acid, an aluminum sheet, acts as negative electrode, aluminum object like spoon to be anodized is taken as positive. This aluminum gets a layer or it oxygen gas liberated at anode, hydrogen gas liberated cathode. This is the positive oxygen. One of the advantages of anodization of aluminum is increasing the resistivity. That means the corrosion tendency to be enhanced. These are the industrial agents. Okay. Thank you.